everyone. Today's objective is simplifying rational expressions. The definition for rational expression is an expression that can be written in the form P over Q, where P and Q are polynomials and Q cannot equal to 0. That means denominator cannot equal to 0. So in example number 1, evaluate the expression 3x squared minus 5 over negative x plus 1 when a, x equals 2. And you just have to plug it in. I'll show you that right now. Now make sure you also plug it in with proper parentheses or you're going to get the numbers wrong in certain situation. So you have 3 times 2 squared minus 5 over negative 2 plus 1. Now work it out. That's going to be 3 times 4 minus 5. Order of operation, don't forget, it's negative 2 plus 1. And that's going to be 12 minus 5. And that's over negative 1. And that is going to be 7 over negative 1. And the answer is going to be negative 7. And that is going to be your evaluation of expression, rational expression when x equals 2. So go ahead, try example B. For example 1, B is going to be 1. When you plug in your negative 1, and make sure you put it in the parenthesis, because if you don't do it correctly, your negative 1 square, in parentheses square, is going to come out to be negative. So make sure you double check when you punch in the calculator. Going on to the next thing, find the value that makes a rational expression undefined. Now undefined means that we are going to see what we can do to make the denominator equal to 0. It's more like the zero product property. What makes something equal 0? So those two things that has to be combined. Denominator and then they have to equal to 0. Here's the procedure to determine the values that makes a rational expression undefined. 1. Write an equation that has the denominator set it to 0. 2. Solve the equation. So just like a zero product property we used in last section 6.6. So example number 2. Find every value for the variables that makes the expression undefined. What we really have to do, for example, C is going to be denominator 3y minus 2 equals 0 and solve it. And then 3y equals 2 divided by 3 divided by 3. That means y cannot equal to 2 over 3. If y equal to 2 over 3, that will make rational expression undefined. Example 2D. For example 2D, if you guys remember, to solve x squared plus x minus 12, and then in zero product property, we are going to just put x squared plus x minus 12 equals 0, solving zero product property. And that's going to be 1 and 1, and 12 is 1 and 12, 2 and 6, 3 and 4. And in this case, you just do 3 and 4, and that's positive, that's negative, and you should have that's negative 3, that's positive 4, that's 1. And you got your zero product property, x minus 3 and x plus 4, and that's equal to 0. And if you solve it, that's x minus 3 equals 0, x plus 4 equals 0, and just solve the little equation, and you should be able to get the undefined value for this equation. So x equals negative. Now let's go back and take a look at it, why this thing works. So if we just plug it in, let's use a different color pencil. So if you plug it in, let's just say 3, okay? Let's just check. Why does this work? So if you do 7 over 3 squared plus 3 minus 12, and that is going to be 7 over 9 plus 3 minus 12. And by looking at it, you can totally understand that will be 12 minus 12. And that will be 7 over 0. And that is why it's undefined on the problem. So make sure you understand what is it. It's all those numbers that will make your problem equal to 0. So by checking 3, you get 7 over 0. That's undefined. If you plug in 4, you will also get the undefined. So I want to put in another color so you can take a look at it. If you take a look at the green part, I also check with negative 4. And that is also making 7 over 0. So those two values, if you plug into the whole problems, will make the denominator equal 0. And that's what forced the whole rational expression to be undefined. We are trying to find the value when the denominator equals 0. And that's what the whole process means. So example E, I would like you guys to give it a try, and we will come back and discuss it a little bit more. For letter E, some of you guys have decided to set it up, which is totally good. And then you try to solve it and you don't know how because somehow you have an n squared equals -9. And you kind of think about it, if you really stand back and just think about it, no matter what you do, n could be positive, negative, but if you square, it's always going to be positive. So therefore, there's no way I can get it to 0. And it's always going to be positive. N squared plus 9 is not going to be able to equal to 0. And because of that, every single number works. So there's no such a thing as undefined. So what we're going to write down is defined for all real numbers. So that means all work. N is going to all works. N is an element, if you want to, all real numbers. You want to write that too. That is kind of situation that's a little different than the other one because the denominator cannot equal to 0. So let's letter E. Next idea is simplifying rational expression to the lowest terms. To do that is to simplify a rational expression to the lowest term. 1. Factor out the numerator and the denominator completely, doing them as two little separate problems, one on top, one on the bottom. 2. Divide out all the common factors in the numerator and denominator. So anything that's the same, we're going to cancel out, provided they are only multiplying each other. 3. Multiply the remaining factors in the numerator and the remaining factors in the denominators. So let me demonstrate how that is done. So for example, simplify example number 3. I believe you guys have some idea how to do this before. What we're going to do is we are going to take the ones that have the factors. If you write this out, this is really just going to be 3 times x 5 times. And the bottom is really 3 times 5 times x twice. So if you talking about factor, please understand they are all multiplication in the middle. If you have addition, you absolutely cannot do this. You can cancel out the 3 and the 3 and the x and the x and the x and the x. And the answer is going to be x to the third over 5. Do I need to show the work by spraying them out? Absolutely not. You can do another way. So you can say 3x to the fifth over 15x to the second. Now what you can do is you can just cancel out 3 and 15. You can say that's 5 on the bottom. And then I told you guys how to cancel things. So x to the fifth, x to the second. Who has a bigger one? Well, you know that it's going to be 5 is bigger. So that's going to be 5 on top with x to the third power left. And then you can just write it down. So that's just going to be x to the third over 5. But there's some sort of work should be showing. On the simple one, this is okay. But as the problem gets harder, that is not going to be okay. So that's example number 3. I would like you guys to try example number 4 yourself. And as the time goes on, I probably will have you try more problems just because I expect you guys to know how to factor. I expect you guys know how to cancel. Number 4. I hope you guys notice how I did the problems. I don't have a calculator just in case, so I actually put 72 and 60, and I put out what they have in common, and that essentially is canceling. And because they both have 2, I can cancel 2 on top, cancel 2 on the bottom. Then I can cancel again 2 on top, 2 on the bottom, and that gives me 16 left for the 72 on top, and then 60 become 15 left with the bottom, and I just did my letters. So that's one way you can do it, or you can do it on the calculator and just do 72 divided by 4 and 60 divided by 4, and you should get the same answer. That's example number 4. Example number 5, I will give you a hint, that is factor out something in the denominator. For example number 5, I factor out 3. Now notice it's 3 times a plus 2. Because 3 times a plus 2, wherever is your multiplication is the sectioned off that you can cancel. So therefore the 9 can be canceled with the 3, that's 3. But the a cannot because that's a plus 2. You can only think about canceling when there is a multiplication happening. So go ahead try number 5. Oh, go ahead try number 6. Again, factoring first before you cancel. 6. The same kind of things right now I want you guys to think about. If we are talking about the multiplication, this is a multiplication, that is a multiplication. And then, so in this case, when you do multiplication canceling, you are canceling x plus 4 and x plus 4. That's a group. And then you can cancel the x and the x. So the answer is going to be 2 over 3. That's example number 6. Please try example number 7. For example number 7, I factored out the y squared minus 16. And that is going to be y plus 4 and y minus 4. At the bottom, I have y squared plus 4y minus 32. And I know that's the 3 term. And I'm going to find the combination. And in that case, when you factor out, it's y minus 4, y plus 8. And I notice where is the multiplication stop and start. So y minus 4 is a group and y minus 4 is a group. Those can be canceled because they both have multiplication, and that's parenthesis. So the answer I left with is y plus 4 and y plus 8. That's example number 7's answer. Please from now on box your answer so it's easier for me to see. Example number 8. Example number 8, I would like to give you guys a hint, which is first factor out the GCF, then take a look, can you factor them? Please try them now. Example number 9, you still have to factor out what they have in common. So I pulled out the 3, and then that's going to give me x squared plus 2x minus 8. And please factor that. On the bottom, I would like to go through it with you guys because it's a little bit tricky. So then that's going to be x squared plus 4. That's first one. And then you also have an x squared minus 4. Because you can square root that that's a difference of a square. Then because of that, you can have the next thing going to be x squared plus 4. And then you can actually have x plus 2, x minus 2. And then please factor the top and cancel. Let's check the answers later. After I factor, I have the ones that I written top and bottom. Then I'm going to take the time and cancel them. And to cancel them, I should have x minus 2 cancel out with x minus 2. And that is it. And your answer, just write down whatever you have left. That's going to be 3 times x plus 4 over x squared plus 4 times x plus 2. And that will be your answer for example number 9. Please try example number 10. At least try to factor. For example number 10, I know most of you guys probably factor the top and you factor out the bottom with a 2. Can I cancel the x minus 4 and 4 minus x? Not quite, but they are very similar, but the position was changed. What we're going to do is, if you guys notice, if you read about it, the x is positive on top, x is negative on the bottom. 4 is negative on top, 4 is positive on the bottom. To switch the order with the opposite sign, what we're going to do is, I hope you guys remember, pulling out a negative, 3x plus 5 on top, x minus 4 on the bottom. Does it make any difference? No, which one it doesn't make any difference which one you write it. So that's going to 2 negative x minus 4. Did you notice? Because I pull out negative, I get to switch the x minus 4. Now, I can cancel, so x minus 4 cancel out, x minus 4 cancel out, and the answer I have left is going to be negative 3x plus 5 over 2. And that's your answer. And that's example number 10. Please try example 11 yourself. So for example number 11, I hope you guys recognize one more time x minus 2 minus x and x minus 2. What would you need to do? You need to change the position. In this case, that's going to be x times, let's put the negative out front, the negative x minus 2 over x minus 2 times x plus 6. And when you cancel them, just like what we had before, and it's going to be x minus 2, x minus 2, and your answer we're left with negative x over x plus 6. And that is example number 11. Example number 12. I would like you guys to think about something we learned as the cube. You must learn how to. So this is going to be A, and this is going to be, and please remember, that's going to be A minus, that's C. C, C, C. So A minus C, first one, the first two, second two, and last two. So that's going to be A squared. And since this first one is minus, you're going to put plus AC and plus C squared. And that is the top. And the bottom is going to be A plus C and then A minus C. And then now you can cancel. So just A minus C can cancel out with A minus C, and the answer will just be A squared plus AC plus C squared in parentheses over A plus C. And that would be your answer for number 12. Moving on to example number 13. Those are our grouping. Please try number 13 with the grouping problem. Number 14 is just switching the sign again. Try those two problems and check back with your answer, please. For examples 13, the one thing I want to remind everyone is don't forget it's a 4-term grouping problem, so therefore the top, the numerator has a negative sign, so therefore you have to change the sign. So when you group it, make sure you change the sign between third and fourth term. On the bottom, you don't have to. So once you group it correctly, you can cancel, and the answer is A minus D over A plus D. The next one is again practicing the sign change. If you pull out the 6 on top, you have V minus 2. If you pull out the bottom, you notice that's a V minus 2, but in opposite position. So I just write it with the negative sign. And once I cancel V minus 2, negative 6, that concludes the notes for this section. Thank you so much for watching.